Well, welcome to Algebra Simple's last video, at least the last video for Algebra 1. And since today we're going to be studying interest, specifically we're going to be studying compound interest. But before we do, remember when I introduced you to one of my friends and her name was Fluffy? Well, I have another friend. And her name is Brownie. Hey, look at her. Isn't she just the cutest little puppy you ever saw? I'm not sure as cute as Fluffy. They're both tied, I think. And Fluffy's a little, or Brownie is a little shy, so we're going to put her down, let her do her thing while I explain everything you need to know about interest and compound interest. So let's look at something really simple, $100 at 10%. Well, $100 at 10% is $10, and I'll show you how to do that in a little bit. But for those of you who know how to multiply interest, $100 at 10% is $10, so that at the end of 1 year you would have $110. And so at the end of 2 years, you have another $10, right? And so that would be $20. And at the end of 3 years, you have another $10, which would be $30. And at the end of 4 years, you have $40. Now, there is an idea, oh, it's more than just an idea, it's a reality of compound interest. And so at the end of 1 year, I have $110, just the same. But at the end of the second year, I have $121. See, I only had 120 here. Now I have $121. Why is that? Well, because the 10% interest is not on the original $100. At the end of a year, I have $110. So I'm getting 10% interest on the $110. And so at the end of 2 years, I have $121. And at the end of 3 years, I have $133.10. I think that says 10 cents. I can't read it. It's so small. And so you can see this was just $1 more, and this is like $3 more, a little bit more than $3 more. And so that's like real interesting. Why? Because we're not multiplying the 10% interest times $100. We're multiplying it times $121. So that's what we call compound interest. Compound interest is interest on your original principal. Principal means the amount that you put in the bank or the amount that you invested. And you get 10% interest on that. Compound interest is you get interest on your principal and your accumulated interest. And so I'm getting interest on the second year, I'm getting interest on $110. On the third year, I'm getting interest on $121. On the fourth year, I'm getting interest on this $133.10. And what do I end up getting? At the end of 4 years, I get $146.41. At least that looks like 41 cents. I'm looking at this backwards, by the way, so I have to read this backwards. And so, look, I've got like $6.41 more than I do over here. If $6.41 doesn't sound like a lot of money, believe you me, it is a lot of money when we're talking about numbers bigger than $100. And so let's first off look at how interest works. This is our principal. And when we say at 10% interest, it means we're going to multiply it times 10%. Now let's look at what 10% is. Percent means parts per 100. So 10% would be 10 parts per 100 or 10 over 100. So if I said 18%, that would be 18 over 100. Now, if you use your calculator, by the way, for this lesson, this is going to be the only lesson where you absolutely need a calculator. Maybe I shouldn't say absolutely. I'm not sure how you would do this without a calculator unless you're putting numbers into Google or something crazy like that. I did that myself one lesson, if you remember. So 10 over 100 equals 0.10, and I know a lot of people like to put 0.10. You can do, I think that's just extra writing. I'm not sure why people do that, whether it's easier to see. I think it's more difficult to see, but you do whatever you're comfortable with. And so you can see that if we're saying percent, 100 at, which means times, 100 times 10%. Now you probably have a function on your calculator where you can multiply times 10%. I've never used that function. I don't like that function. I always convert this to 0.10. By the way, obviously you don't need that zero. I just put that in there to remind us we're talking about 10%. Okay, so the easiest thing to do, you don't want to do all this nonsense. I shouldn't say nonsense. You don't want to do all this hard work. Put the 10 over 100, put that in your calculator, and it gives you 0.10. All you need to do is take the decimal. Remember, if we don't have a decimal point, the decimal is behind the last number on the right. Is that on the right? I think so. I'm moving to the left, so as you can imagine, all year long, I have been reading everything backwards and doing a pretty darn good job, although I've had to reshoot some of these scenes because I'm looking at 2s and they look like 6s and things like that. But anyway, the decimal is right here. If the decimal is not there, if you don't see a decimal, then it's after the last number. 10 is our number, so the last number is 0, and so it's after that. So move it forward 2 places, and then that's going to give you the 0.10. Okay, now let's look at our first problem. Okay, this is our formula for compound interest, and it's not too complicated. You do need to memorize it. And A stands for amount. Amount is how much money you have when the whole problem is over. So some of these problems are going to go on for 10 years or 35 years, however long they go on for. And it's the amount that you're going to have when all the years are over. And A equals principal. Principal is the amount that you put in the bank or the amount that you invest to begin with. So P stands for principal, the amount that we're starting with. Sometimes you'll see A sub T, and that means at the end of that time. And instead of P, they put A sub 0, which means the amount that we start with. So you're not going to need to know that for Algebra 1, but, again, we have the SAT and the ACT and the ASVAB coming up, so if they do something a little bit different, just know that we're talking about the same thing. And so the principal is times a parentheses of 1 plus. Now the 1 represents the principal. Remember, we're going to have interest, but not just interest. We want our principal back. And so the 1 represents the original investment, the original principal. 1 plus rate over number of times per year that we compound. Now the rate is the interest rate, and n equals the number of times we're compounding during the year. Now we may only compound once a year, like I was showing you with our original $100. We were compounding that only once a year. But we're going to see sometimes we compound 4 times a year, and sometimes we compound every day of the year. So if we're compounding 4 times per year, Guess what goes into that n there? The interest rate's going to go where the r is, and the number of times that we compound during the year is going to go where the n is. Now let's close that parentheses, and our exponent is going to be that n again, that is the number of times we compound during the year. That is, we insert the n twice into our formula. And we multiply that n times time. That is the number of years this will be going on. We may be investing our money for 3 years. We may be investing our money for 35 years. It just depends on how long you want to invest your money. But that number of years is going to be multiplied by the number of times we compound it, and that's going to give us our final exponent. And you're going to want to multiply n times t before you do any of your work. So let's look at our first problem. If you take a car loan for $25,000 with an interest rate of 6.5% or 6.5%, compounded quarterly. Now what does quarterly mean? Quarterly means 4 times a year. Now real quickly, in a lot of these problems, they're not going to tell you how many times a year you are going to be compounding. You're going to need to decipher that with words like quarterly. No payments are required for the first 5 years. What will your balance be at the end of those 5 years? Okay, for compound interest, sometimes we are going to be putting money in the bank. Sometimes we're going to be borrowing money. Sometimes we're going to be making investments. So just be careful that it doesn't matter whether we're borrowing money or putting money in the bank. It doesn't matter whether they are paying us interest or we are paying them interest. Anyway, the amount is the amount at the end of 5 years. We don't know what that is. That's what we're trying to find out. And what are we borrowing to begin with? Remember, this is the amount of money we would normally put in the bank, but in this instance, we are not investing. We are borrowing. We're doing just the opposite. But this works exactly the same way. 25,000 times parentheses 1 plus. Now it's always going to be 1 plus. Always. So 1 plus an interest rate of 6.5%. Now you didn't put 0.65, did you? Because I had a student this week do exactly that. They put 0.65. Now 0.65 would be what? 65%. 6.5% is just move that decimal point 2 places. And since you don't have 2 places to push it, throw another 0 in there. Okay? 6% interest is 0.06. Now I know it's 0.065 because it's 6.5%. But anytime you get an interest rate lower than 10, if it's 9, it's 0.09. If it's 3, it's 0.03. Be real careful because that is a real common mistake to make. And the number on the bottom is of this fraction. The denominator is the number of times we're going to compound per year. Do you remember how many times we're going to compound? Quarterly. 4 times per year. Okay. And that parentheses has an exponent of t times n, or n times t. N, like we just saw, was 4. It's quarterly. And do you remember how many years we're going to borrow for? Well, if you go back and read the question, it's for 5 years. Now, do you know where to start as you're solving all of this? Do you remember PEMDAS? I believe it was our 3rd lesson. If it wasn't our 3rd lesson, it was our 4th lesson. And that was pre-algebra. So that's not even algebra. So PEMDAS is parentheses first. And within our parentheses, we see 0.065 divided by 4. that will equal 0.01625. And so we're still working within the parentheses. Let's add 1 to that. That was pretty simple, and that is how almost all of our problems are going to work out when it says 1 plus the interest rate over the number of times we compound. You're just going to get rid of that plus sign and move the 1 over. Like I said, 98 to 99% of the time. If you had to add it to something that's, if this is greater than 1 right here, well then obviously that's going to be 2 or 3 or whatever. But anyway, we have everything in the parentheses completed. So PEMDAS, let's see, parentheses, exponent. Oh, let's work on that exponent. 4 times 5 is an exponent of 20. And now you see why we're going to need a calculator for this. Could you multiply this number times itself 20 times? Yeah, I suppose. How long would it take you? Half hour to an hour. How long will it take you with a calculator? No time at all. And that answer is 1.38042. Now, I told you before, for our answers, we only need to go 2 decimal places unless they ask for more. But I also told you while I'm doing my work, I like to carry that decimal point out, to the point where it starts getting a pinch absurd, because we're going to be multiplying that times a big number, 25,000. And so we're going to have to pay the bank back or the car dealership back or whoever we were borrowing that money from. And we're going to have to pay them back in dollars and cents. They're going to demand an exact amount from us. I guarantee you they are. And so that is the number we came up with. Let me show you how we accomplished that. This is my graphing calculator, the TI-83 Plus. There are lots of good calculators. This is a pretty common one. But I'm going to show you how to do this function on the TI-30X2S. Type in 1, hit the plus sign, enter the rate, 0.065. Then to create a fraction, just hit the division sign. Enter 4. So we have 0.065 over 4. Then hit the enter sign, and that gives us 1.01625. That is all the work within the parentheses. Now let's apply the exponent, which was 20. To apply an exponent, you hit the caret. This button right here. On the graphing calculator, you perform that the same way, except that the caret is on the right-hand side of the calculator. Once you hit the caret, type in 20. And then hit enter. Multiply that times 25,000. Hit the enter button. That button is called the enter button or the equal button. Although on the graphing calculator it says enter, it does not say equal, but it works in the same manner. $34,510.49. And that is our answer. Now when I did my calculations, this is not the number I used, because this number is rounded off here, and I think it goes like 197, or I can't remember what it does, but it gets a lot more accurate than this. I just rounded it off after 1, 2, 3, 4, 5 decimal places. That's pretty darned accurate. And if you use this number, this is what you came out with. You came out with 50 cents. And here we have 49 cents. So here you're off by a penny. Now, is far as I'm concerned, for homework, I don't care. As far as the test is concerned, I don't care. If you're off by a penny when we're talking about $34,000, that's accurate enough for me. However, getting back to the SAT, ACT, and all those wonderful things, I don't know how accurate they're going to demand from you, and if they'll take off 1 point out of 10, I don't know. But the number that I used was on my calculator, and I put it in my memory before I multiplied it times 25,000. So the number I had was perfectly accurate, and it came out to a perfect 49 cents, whereas you came out to 50 cents if you are rounding off here. So you might want to keep that in mind. You don't have to. For Algebra 1, this is accurate enough. But if you want to be perfectly accurate, use the number on your calculator and don't round it at all. The minute you round it, you're going to be off by 1 penny. So let's try another problem. If $4,000 is invested in an account paying 3% interest compounded monthly, again, they're not telling us the number of times a year we're going to compound. They're giving us a word like quarterly and monthly. So what does monthly mean? That's right, it means 12 times a year. So n is going to equal 12. What is the balance after 7 years? Did you notice that I'm doing the same thing that I did for the quadratic formula? I write the formula here, and that makes it a lot easier to insert numbers. Now, what is A going to equal? A is going to equal the amount after a certain number of years, and that's the question. How much are we going to have after a certain number of years? Now, what is the principal? The principal, which is the original amount, is $4,000, and we're going to multiply that times a parentheses of 1 plus. It's always going to be 1 plus. Our rate is 3%. That's 0.03. And it is going to be compounded 12 times every year. So that's going to give us an exponent of 12. We're using that n again. 12 times 7 years, which is the number of years that we are going to have our money in that investment. We don't know what the investment is, whether it's bank or real estate or who knows what. But I hope this was a lot easier than the last time. The last time we were doing this, maybe this seemed a little foreign to you. But this time, you can see we're doing pretty much exactly the same thing, only with different numbers. So 12 times 7 is 84. And by the way, like I discussed in the last problem, we're using exponents that are much bigger than the exponents we're used to using in Algebra 1. But when we get into compounding, we're going to be using just huge exponents. And so previously in Algebra 1, we could have done all this work with or without a calculator, depending on what your ideas are about calculators. We've gone over that before. But when it gets to something like this, you're just not going to be able to multiply anything times itself 84 times. And if you do take the time to do it, I can't imagine that you're going to be accurate. You're going to have to make a mistake somewhere. But getting back inside the parentheses, oh, we were supposed to do the parentheses first. Well, it's not going to make any difference, but that was bad. Shouldn't do that. I shouldn't do that. And getting back into the parentheses, we've got 0.03 divided by 12 is going to be 0.0025, and we're going to add it to the 1, and it's going to be 1.0025. And so after our parentheses, we're going to do our exponent. And so we're going to multiply that 1.0025 times itself 84 times. Let's do that. And we're going to have 1.23335. If we only carry that out 5 decimal places after that, I believe it's 4801. And like I said, I use the number on my calculator, and I'm not going to write out the whole number here. That gets a little bit tiresome. But let's multiply these two numbers. And our investment will grow to $4,933.42. Now let's try the same problem, and instead of compounding it 12 times a year, we're going to compound it every day. If $4,000 is invested in an account paying 3% interest compounded daily, again, it's given us numbers like quarterly, weekly, monthly, daily, and you got to turn that daily into a number. What is daily? How many times a year is daily? It's 365. So I think you got the entire vocabulary for a year. I don't think we did weekly, but weekly would be what? 52. Anyway, be careful of that. It's not always going to tell you the number of times per year that they are going to compound it. Compounded daily means 365 times per year. What is the balance after 7 years? Okay, and we have $4,000 that we invested, and that is going to be multiplied times a parentheses of 1 plus the rate, 0.03. Remember that 0 in front of the 3. It's not 30% interest, it's 0.033% interest, over the number of times we're compounding, which is 365. And we will have an exponent of 365, the number of times we compounded, times the number of years, which is 7. So the number in the parentheses is 1.0000, that's 4 zeros, 82192, and that is going to have an exponent of 2,555. Now let's apply that exponent, and that is going to be a number of 1.233668, and we're going to multiply that times 4,000. And we will have an investment of $4,934.67. That's if we compound it daily. Do you remember how much we had? Same principle, same number of years, but we compounded it monthly. Yeah, we only had about $1 less. So while your answer may be important as far as a test or Algebra 1 goes, if I'm asking you to invest some money and somebody says they're going to invest it they're going to compound our interest daily, and another brokerage firm or another bank says we're only going to compound it monthly, am I going to make a big deal out of that? No. I care more about what the interest rate is. That will make a big difference. Now it is important that it's compounded, because look what happens when you don't compound it. If you don't compound it, we're only going to receive $4,840. Well, that is a big deal. That's almost $100 difference. So, and I call that straight interest. That, by the way, that's what the banks call it, and that's what investors call it, straight interest. That means not compounded at all, just straight interest. So you can see it's very important that your money or your interest is compounded. But how often it's compounded is just not that big of a deal. Maybe it's a big deal if your name is Warren Buffett and you have billions of dollars, and you know, I don't know what the difference would be, a couple $100 and maybe a couple $1,000. But how often we compound is not that important as far as our investment is concerned. As far as these calculations are concerned, you can see that there's a difference on how we calculate it. But that's it. That's everything you need to know about interest. That is everything you need to know about compound interest. And that is everything you need to know about Algebra 1. You are done as soon as you do your homework and take that last test.